Let's talk about polymorphism. All right. We are back in Eclipse, back in our IDE. Let's go through some examples of polymorphism. Let's start with overriding. That's our runtime polymorphism. If you look at the word overriding, it almost looks like it's running. So you can use that to remember runtime polymorphism. But let's take a look at our animal and dog classes. So we'll go to the animal class. So I've done something I don't normally do, and that is put two classes in the same file. But I've done this for demo purposes and to conserve space because look at how many classes I have here. So we have our animal class and we have our dog class. The animal class has a method of speak. The dog class also has a method of speak, which it inherits from animal. So what we have done here is we have changed the implementation in the child class so that this animal or this extension of animal, which is dog, barks when it speaks, as opposed to the animal, which just makes a generic animal sound. So let's go back to our runner class and run this and see what we get. So we're going to run this. So we have an animal and it's instantiated as a dog and it's going to speak to us. This dog has spoken to us and it barked. So this demonstrated that a child class can override a parent method and implement it in its own fashion. So let's comment this out. Let's move on to the next example. So the next example here is method overloading. So we're going to go to our friendly little calculator class because it seems that other than like animal and vehicle classes, you seem to like calculator classes in Java. So let's take a look. So we have our class calculator. We have an example of method overloading. And as you can see, same method name, different parameter lists. So we have 4 different add methods. And look at the parameter lists. So here, the types of the arguments are different. The number of the arguments are different. And when you're resolving this at compile time, what the compiler is looking at is the name of the method and the parameter list. These return types, yes, it's good. It's good for type safety, but as far as overloading, it doesn't matter, at least not for the compiler at the time of selecting the method. Okay, so we have talked about it. And one thing I would like to say is, although inheritance is not required for overloading, it is possible to overload methods in a subclass. It is possible. So just keep that in mind. Child classes can override and overload methods. But let's focus on the matter at hand. So let's go back to our runner class. Okay. Let's make sure this is saved. All right. And let's run this and we'll see what we get. So these methods, they all run and they all run in their own ways. So this adds 2 integers and gives you 5. This adds 2 decimals and gives you 6.0. This adds 3 numbers and gives you 6. And this concatenates a string and gives you hello world, which is another programming favorite. So let's comment this out. And let's move on. Now we're going to deep dive here. So now we're going to get into the advanced topics. So let's talk about the final keyword. For some reason, I like saying final. But let's go to our base class. So we'll go to base. And again, I have 2 classes. I have 2 classes in one file, which is what I don't normally do. But we're going to demonstrate that final classes I mean, well, final classes cannot be inherited, but we'll get to that in a minute. So let's talk about what happens if we try to override a final method. A final method. All right. Okay. So yeah, this is a non-starter. Cannot override the final method from base. So this is a non-starter. I'm not even going to run this because we know it's going to fail. Okay. Let's see what happens if we put the final keyword in front of base. Okay. And let's see what happens here. The type derived cannot subclass the final class base. Remove final modifier. So yeah. So these are non-starters. It's not happening. It's just, yeah, sometimes there's just some things that can't happen. So let's run this anyway, now that we've corrected it. And essentially, what you have is you have it's just inheritance at this point. Like the child class is inheriting a final method. And this is the next point that I need to make. Final methods can be inherited, but they cannot be overridden. I'm going to say that again. Final methods, they can be inherited, but they cannot be overridden. All right, let's move on. So we're going to talk about constructor overloading and constructor chaining. So let's talk about our user class. So we'll go to our user class here. And it's nice to have a file with only one class in it. So this is demonstrating how you can use the this keyword to perform horizontal constructor chaining, cutting back on duplicate code. So essentially, these are all so these two constructors are calling this constructor. So horizontal constructor chaining is basically calling a constructor within the class, as opposed to vertical constructor chaining, where you're calling the parent constructor in a child class. So let's go ahead and run this. So let's go back to our runner class. And let's go ahead and execute this. Okay. And it works as expected. And here we used 3 different constructors to instantiate the user object in 3 different ways using horizontal constructor chaining. Okay, let's talk about covariant return types. So covariant return types is when a child overrides a method and uses the base class, the child class is a return type. So let's go to our parent class. Oh, and look at that. We have 2 classes. One's a parent and one is a child. So this is similar to the example we were talking about in the didactic portion of this video or other video. So we have a get method, and these get methods are basically returning themselves, essentially. But the point is that this child method, so this child inherits the get method from the parent, but it returns the subtype of the return type that the parent method is returning. So this is what is known as covariance. And this works for inheritance. So let's run this. So we'll go back to our runner class. All right, let's go ahead and execute this. Okay, so the returned object is of type child. So that demonstrates that you instantiate a child object. And then and then you create another object, which is the returned object from the get method, because this get method is returning a child object. So the returned object is of type child. There we go. So let's comment this out. Okay. So here's the overriding equals hash code into string. So let's go in order. So let's comment this out and save it. So let's look at our person class. So we have a person. Okay. So we have a person. We have two attributes, a name and an age. We have our constructor, our getters and setters. Okay. And what we're going to do is we're going to override the equals method, hash code method, and toString method. But before we do that, let's go ahead and run this program. So we'll just go back to the runner class, just so that we know what we're looking for. So we're going to print. So we're gonna print the equals hash code. So we're instantiating two person objects, person one and person two. So we're going to print their hash codes and their toString. So let's run this and print this. Okay, so this is false. But wait a minute. These two objects, they have the same information. They're both named John and they're both 30. And you're comparing these objects, but it's supposed to be true, but it's telling you it's false. That's why I have to override the equals method. If you're planning to do a comparison, you got to override that equals method. Then, of course, the hash codes are different, which is why this method is resolving a false, because if you have two different hash codes, then equals is going to resolve to false. And then this toString, so it's giving you this funny looking thing, I guess. I mean, it's a string, but it's anyway. I just don't. Nobody really likes the way it looks. Like all you know is that okay, it's a person object, but you don't know anything about it. Now let's refactor these three methods. So let's go back. So let's roll this thing back. So we'll go to the person class. So let's override the equals hash code into string method. And we're going to do this in a few button clicks. So you're going to right click. You're going to go to source, generate hash code and equals to. And notice that they're together, generate hash code and equals. Because if you're overriding the equals method, you have to override the hash code method as well. So we'll do this. And then we're gonna pick these two fields because it's going to be compared to fields. So when you override the equals, you're going to compare these fields. So we're going to hit, and this is pre-selected. So all we have to do is hit generate. Okay. And now we have our hash code and equals methods. So all done with just a few clicks of the button. And this is what we do in industry. We're not, I mean, we're not writing this out. You could, but do you want to? Now let's do the toString method. So we'll go to source, hover over source, generate toString. You select your fields. And of course, if it's a child class, you can also go to inherited methods and select, but we don't have any inherited methods, but you can select inherited methods as well. But anyway, let's just generate this. Now we have a toString method. So we'll save this. We'll go to our runner class. And then we'll run this. Notice how everything now just works out. Person one equals person two. It's true. Both hash codes are equal. And now we have some useful information in this printout. We have a person object, and we can see what the attributes are. We have a person, their name is John, and they're 30 years old. All right, let's move on. Okay, so this is where we're going to look at a class with overloaded constructors and refactor these constructors using constructor chaining. Okay, so we're going to go to the worker class. And we can go ahead and run this as it is. Okay, so it works. So let's go and refactor this code. So you're going to have times as a developer where you may write some code and they may work, but you may have to refactor that code. And refactoring the code could involve breaking the code before you get it to work again. So we'll refactor this. So we're going to use the this. And I have Copilot, so it's auto-populating these. But if you didn't have Copilot, you just have to type it out. So it's going to be this name, age. I just typed it out just to prove I can still type. This name, age, address. Okay, we're done. We're done. So let's go back to our runner method and let's see if we broke this or not. So let's run this. It still works. Shocking, right? No, not really. Okay, let's move on to the next. So we're going to talk about widening and overload resolution precedence. So widening, as I already mentioned, is basically when a primitive is widened into a larger primitive. So let's go to our widening precedence demo. So we have a widening demo. We have the same methods. So this widening refers to over overloading. So widening in precedence, in order of precedence, exact match first, and then widening. So you're taking this X and widening it to a long. Then autoboxing, which is basically you take a primitive and put it in a wrapper class. Then varargs, which is basically you have you have a list of arguments. Yeah, you have a list of arguments, but not the order, but the number of arguments is unknown. So we're going to go ahead and just demo this. So we're going to go to the widen precedence demo. And we'll run this. Of course, we'll have to save it. Okay. So it ran these methods. So it ran the exact match. So you have a 10. You have a 10. So the 10 is an integer. So you're looking for the exact match. So exact match is integer. So typically, if you pass a number into a method, it's going to default to an int. So the exact match is an int. You have a long, so that's widening. So this L widens this to a long. The widening actually has occurred already. You put an L, it already widened. It's just that the widening is part of the order of precedence in resolution of methods. So you're going to pick this method because of widening. Now you're autoboxing because you took this and put in a class, a wrapper class. Wrapping. So it picks this method. Then you got the varargs. So you have two arguments. So it picks this method. So with this, we are done with the didactic portion, well, the coding portion of this topic. I hope you learned something. Like this, subscribe. On to the next. See you later.